I've spent about a year working on an autorouter for tscircuit, an open-source electronics CAD kernel written in Typescript. If I could go back a year, these are the 13 things I would tell myself. So, you can simply replace the DFS or BFS with an algorithm to get the shortest path. Understanding the basics is a popular pathfinding algorithm used to find the shortest path between 2 points in a weighted graph or network. It is particularly useful in video games, GPS navigation, and other applications where efficient pathfinding is crucial. The algorithm works by maintaining a priority queue of nodes to visit, where the priority of each node is determined by its estimated total cost to reach the destination. The node with the lowest priority is visited first, and its neighbors are then visited, until the destination is reached. The algorithm starts by initializing a priority queue with the starting node. The priority queue is ordered by the estimated total cost to reach the destination from each node. The node with the lowest priority is visited first. The algorithm then explores the neighbors of the visited node and adds them to the priority queue. The process is repeated until the destination is reached. Advantages of A**. Those are the hyperparameters we're trying to optimize. Understanding the problem optimizing hyperparameters is a crucial step in machine learning, as it directly affects the performance of a model. Hyperparameters are the parameters that are set before training a model, and they can significantly impact the model's accuracy and efficiency. Language is not the limiting factor in the development of a new algorithm. Understanding the importance of iterations when it comes to developing new algorithms, the focus is often on optimizing the speed of each iteration. However, this approach can be misguided. The key to success lies not in the speed of individual iterations, but in reducing the number of iterations required to achieve the desired outcome. The more iterations, the more time and resources are wasted on redundant calculations. Trees are not a good data structure for large datasets. They are not efficient for large datasets. Trees can become very slow as the dataset grows, making them impractical for large-scale applications. They are not a good representation of data. Trees do not accurately model the relationships between data points, making them a poor choice for data analysis and visualization. They are not flexible. Trees are rigid and do not adapt well to changing data structures or requirements. The quad tree data structure. The quad tree is a type of tree data structure that is commonly used for spatial data, such as points, lines, and rectangles. Variants of the basic data structure. Overview of the basic data structure. The basic data structure is a fundamental concept in computer science, and its variants are used to represent and manipulate data in various ways. Thus, the next generation of autorouters will be incredibly fast and much more efficient than current ones. The first of these new autorouters are already being developed and built. In the near future, we can expect to see the development of new semiconductor materials and technologies that will enable the development of smaller, faster, and more efficient electronic devices. These new materials and technologies will be the foundation for the next generation of electronic devices, including the next generation of autorouters. As the semiconductor industry continues to advance, we can expect to see significant improvements in the design and manufacturing processes of electronic devices. These improvements will enable the development of smaller, faster, and more efficient electronic devices, which will have a major impact on various industries such as healthcare, finance, and transportation. Spatial partitioning. Spatial partitioning is a technique used to improve the performance of algorithms by dividing the input data into smaller, more manageable chunks. In the context of autorouters, spatial partitioning can be used to optimize the placement of routers and switches in a network. By dividing the network into smaller regions, spatial partitioning can help reduce the number of hops required to reach a destination, thereby improving network efficiency. Understanding the power of visualization. Visualization is a powerful tool that has been used for centuries to solve complex problems. From ancient civilizations to modern-day scientists, visualization has played a crucial role in understanding and solving problems in various fields. This mutability makes the algorithm slower in the best-case scenario. They are often used for optimization problems that are not well-defined or have no clear objective function. The nature of Monte Carlo algorithms. Monte Carlo algorithms rely on randomness to iteratively converge towards a solution. Understanding the Autorouter. The Autorouter is a complex software tool designed to optimize the routing of packages and vehicles in logistics and supply chain management. Normalization and complex transformations. Normalization is a process that involves transforming data into a standard format to facilitate comparison and analysis. It is a crucial step in data science, as it enables the creation of a common language and framework for data analysis. For instance, if you're trying to find the shortest path between two cities, you might be exploring the same road over and over again, wasting time and resources. If B is present, mark the square with a check mark. If not, leave the square blank. This process is repeated for each row and column of the grid. Understanding spatial probability of failure. Spatial probability of failure refers to the likelihood of a system or process failing at a specific stage or location. Then, the problem of finding the optimal solution becomes less relevant, and the problem of finding the optimal solution becomes less relevant, and the problem of finding the optimal solution becomes less relevant, and the problem of finding the optimal solution becomes less relevant, and the problem of finding the optimal solution becomes less relevant, and the problem of finding the time to the optimal solution. This is where the concept of AA is often preferred over other variants because of its completeness property. This property ensures that the shortest path between 2 points can be found using a star. The completeness property allows developers to find the optimal path by starting from any node in the graph. This property is particularly valuable in game development, where games often involve complex paths and players can start from any location. In addition, A is widely used in various fields, such as robotics, computer science, and computer graphics. A is an optimal pathfinding algorithm that uses a priority queue to select the next node to visit. The algorithm starts with the initial node and assigns a heuristic value to each node. The heuristic value is an estimate of the distance from the current node to the target node. The algorithm then selects the node with the lowest heuristic value and visits it. This process is repeated until the target node is reached or the queue is empty. In the context of game development, A is used to find the shortest path between 2 points in a graph. The graph is typically represented as a set of nodes and edges, where each node represents a location and each edge represents a possible path between two locations.